Hello everyone, welcome back to Susan and John MathTube. Today we are going to discuss about cumulative distribution function. I gave you a rough idea about cumulative distribution function in the last video, but I'll be explaining the same question again in this video so that you get a better idea about the cumulative distribution function. So let's start. So as always, let x be a continuous random variable and let our PDF be f of x. And by this time I'm sure you know what's a PDF, the properties, the geometrical meaning, etc. Okay, so the distribution function is nothing but you just accumulate, you just collect all the probabilities from minus infinity to any number. That means we are collecting the sum of all the probabilities from minus infinity to any desired number you like. So this is the practical definition. Okay, you have to note one thing. When you add all the probabilities, we learn that we get 1. So when x is very large, then f of x will be very near to 1. Okay, so let's move ahead. This is the same question which we discussed in the last video, but the last part was not that clear, so let's make it very clear. So we have a distribution function, and we found in the last video the value of k is actually 3. We even went through the graphs, etc., etc. And in this video let's discuss about its distribution function. So let's start. So I hope you remember the PDF is 3x square, 0 less than x less than 1 and 0 otherwise, and we have to find the cumulative distribution function, or simply they call it the distribution function. Just now I told you cumulative distribution function is denoted by capital F of x, and it is the accumulated probability from minus infinity till x. Okay, and this is the formula which we are going to use. So look at this. I have kept the function here so that it will be easy for you. So look at this. When you integrate 0, what are you going to get? Yeah, you will get 0. So that's why I put 0 otherwise. Now let's go to the second one. Look at this. The trick is very easy. Look at the lower limit here. Just take a look at the lower limit here. What's the lower limit? 0. So what I did is I put integral 0 to any number x, and I used the integrand 3t square dt and the same limit. So this gives me the probability or sum of the probability from 0 to any number I desire. Here we get exact probabilities, but here we get the probability from 0 to any number I desire from 0 to 1. Okay, now it's just integration and put upper limit, lower limit, you get this. Now one very important thing. This quantity should be defined from minus infinity to infinity. We have reached from minus infinity to 0 and then from 0 to 1. So look at this. The accumulated probability here is 0. And the accumulated probability over here is x cube. So the definition ends here. So what we do is we use a trick. We just write 1 if x is, tell me the last number here, yeah, greater than or equal to 1. I hope you got the point. This is how we define the cumulative distribution function or our capital F of x. And this gives me the sum of all the probabilities from minus infinity to any desired number I like. Okay, let's move ahead and make things clear. So, let's go for the first question. If a random variable x, of course continuous, follows a PDF given by, so we have a PDF over here, then naturally, because we have to find the value of k, and second one, the cumulative distribution function, that is our capital F of x. So we start with the PDF, and I'm 100% sure now you know how to find the value of k. So can you try it yourself? Okay, I have the properties. So the properties are like a PDF should be always positive, and second one, if you add from minus infinity to infinity in a continuous scale, the answer will be equal to 1. Now I'm going to split the integral according to the function. So I made it like minus infinity to 0, and then 0 to 1, and finally 1 to infinity. And I'm sure that you know these values. So look at this. From 0 to 1, we are supposed to use this. And if it is less than 0 or more than 1, you're supposed to use this. So we end up like this. This function value became 0 and the integral became 0. Same thing. And here we have a function value. Okay, now I'll take this k outside and I'm going to expand this a minus b the whole square. Then I can distribute so that I'll be able to integrate. I hope you're working out the problems with me. So integrating x to the power 3 becomes x power 4 by 4, then the step, and then this. Now you're supposed to put the upper limit instead of x minus the lower limit. Wow, we got the value of k. Now I think you can see the PDF on the left side of the screen. So now we have to substitute the value of k. So I hope things are good till here. Now let's go for the second question, and this video is dedicated to that second part. Okay, so let's start. What do you mean by CDF or the distribution function? Yeah, it's the accumulated probability or the sum of probabilities from minus infinity to any desired number you like. And the practical way of doing it is integration. Okay, now like before, if you integrate 0, what will be the answer? So I write 0 otherwise. Okay, now look at this. We go from minus infinity to 0, and then 0 to 1, and 1 to infinity. Here the probability values are 0. So if you add 0 plus 0 plus 0 plus 0 plus 0 plus anywhere, you get the answer 0. So the accumulated probability will be 0 till here. And here the function is defined like this: 30 by 77 x cubed 4 minus x square. So we had to use integration and find the value. And the values after 1 in the PDF is actually 0. But remember, the accumulated probability will reach 1 at this point. So for the last interval, you have to keep the value 1. Okay, let's start. So here we go. I took the lower limit to any number than 1. I hope you're okay with this. Now it's just integration. So what I did is I had kept your capital F of x over here, and I'm going to do this integration. Okay, and I want all of you to try the integration by yourself. Don't just keep on watching the video. While you watch the video, you get the concepts, but if you want to do the same questions in the exam, make sure you take a pen and a paper and work out the problems along with me. So in the next step, we are going to expand a minus b the whole square, and then you can distribute t cube, and now we are ready for integration. And that's it. Put upper limit minus lower limit. Of course, when you put the lower limit, you're going to end up at 0. Okay. So here we have capital F of x. Now the integral is almost ready. So you put 30 by 77 outside, and then this is the integral value. Okay. So I hope you're okay with the answer. So let's go for one more question, and that's very important. So as always, we have a continuous random variable with distribution function. Okay, so the distribution function is given, and the question is very simple. Find the mean and variance. Okay, so the function is defined from minus infinity to 0 and then 0 to infinity. So it's just two pieces. Okay, and the most important point to notice is you're given capital F of x, not small f of x. And if you want to find mean and variance, we usually use small f of x. Okay, so our job is to find small f of x, and that's very, very easy. All you have to do is differentiate. So let's start. Let small f of x be the required PDF, the probability distribution function. Now, I told you if you want small f of x, we have to differentiate. And this is how we differentiate. What is the derivative of 0? Of course. And what is the derivative of 1 minus e to the power minus 3x? 1 will become 0, and e to the power minus 3x becomes e power minus 3x into minus 3. And on simplification, we get this. Now, this is a straightforward question. You know the PDF, and you want the mean and the variance. I hope you still remember the formula for mean and variance. Mean is integral x into f of x dx. Now we split like minus infinity to 0 and 0 to infinity. You can see it's a two-piece function. Okay, so we have minus infinity to 0, and the function value is 0 over here, and that's why I put 0. You can connect them. And from 0 to infinity, as using that capital F of x, go for small f of x. Okay, so anyway, the first integral will disappear, and now we have a situation. I'm sure as engineering students you have learned about improper integrals. This is actually an improper integral type 1 because the limit is infinity. And when the limit is infinity, you should be very careful because some integrals will diverge and some integrals will converge. So we should use the proper technique to evaluate such integrals. If you do usual integration and put upper limit minus lower limit, you may or may not get the answer. There is no guarantee about those things. But whenever you end up with an improper integral, the proper method is you use limits. That means we are going to approximate it. So replace this infinity with any letter you like and make it a limit. That means we are going to find an approximate value. Okay, and we have one more problem. We will be forced to apply integration by parts. I have something really good for you that's called Bernoulli's rule. It's more powerful than integration by parts, but it's ideal only for a few things, not like that ILATE we see in integration by parts. And the rule is very simple. U, V. That will be like U, V bar minus U dash. You do that bar 2 times. You keep on increasing the number of dash and bar. And this dash stands for the derivative. That means you're actually differentiating U again and again and again and again and again. And you can see the ideal situations. I have kept polynomial in all the cases. And I'll give a very simple example, x square plus 1. If you differentiate this, you get 2x. And the second derivative is 2, and after that it will vanish. And that's the reason I have kept the polynomial as the first function. Because you can see that we're going to differentiate again and again and again and again. So we practically will be differentiating till the polynomial will vanish. Okay, and this bar stands for integration. So we're going to integrate the second function again and again and again and again. So let's go for it. I have the rule here, and this is what we were trying to evaluate, the mean. And we have a situation here, we need product rule or Bernoulli's rule, and then we have to evaluate an improper integral. So the integral x e power minus 3. Just forget about the limits for the time being. Let's focus on this. So we have u and v. And as I promised, the first one is a polynomial. So u and then v bar means the integral. The integral of e power minus 3x is e power minus 3x by minus 3. Then according to the rule, it's like plus minus dot dot dot. So I'm going to differentiate this and I'm going to integrate the quantity inside the bracket. That's it. So we have the integral. I took common. Okay, now let's substitute. So this is equation 1. You can see on the left side of the screen. So instead of that integral, now we have this value. Now as usual we have to put upper limit, lower limit. So I'm going to put the upper limit. By the way, I just cancel this 3 and 3. When you put upper limit you get, and when you put the lower limit, because e to the power 0 is 1, you're going to get this value. And now we will distribute the limit, and yeah, I think you're okay with the steps, like e power minus 3t is equal to 1 by e power 3t. So we have infinity by infinity here, because when you put t equal to infinity you get infinity, and when you put e power infinity you get infinity. Anyway, I just applied L'Hopital's rule. I hope you're good with that rule. It's simple. Whenever you have 0 by 0 or infinity by infinity indeterminates, what we do is we differentiate the numerator and the denominator separately till we find the value of the limit. Okay, now that's it. Now I'll try to substitute the limit. I cannot put this infinity anywhere in the limit. T is missing here. And in the denominator, okay, we have the values here. I think you should note these values. Now the denominator will become infinity, and 1 by infinity is 0. You get mu equal to 1 by 3. Now let's go for the second part, the variance. And here we have our f of x and the formula for variance. And as always, we are going to split the integral. It's a two-piece integral, you can see that. So we can write minus infinity to 0 and 0 to infinity minus the value of mu we just found. Of course, the first one is going to disappear because the function value is 0 here, so it will disappear. Now let's not waste time. So let's move ahead. Okay. So as before, you have an improper integral. And when you have an improper integral, you remove the infinity and convert it into a limit. Okay, call it equation number 2. And our favorite rule, the Bernoulli's rule, because you can see we had to apply product rule, and the first one is a polynomial and the second is exponential. And we have the rule being applied over here. So the first function and integral of the second, and what is the derivative of x square? 2x. And what's the derivative of 2x? 2. And inside the brackets we keep on integrating again and again. Okay, and I'm forced to stop here because if you perform the rule once more, the derivative of 2 will vanish and we'll get 0 plus 0 plus 0 plus 0. So we will stop till the first function becomes a constant. Anyway, there's something common. Now it's time to substitute an equation number 2. Okay, now like before, we can cancel these things. If you want, you can take negative outside or you can keep it inside itself. And now put the upper limit instead of x minus the lower limit instead of x. So you get something like this. And it's time to distribute the limits. That's it. And I applied one more property. E to the power minus 3t is 1 by e to the power 3t. So as before, we have an indeterminate form. You can try substituting t as infinity. You will get infinity by infinity. But the good news is, if you have infinity by infinity, L'Hopital's rule can be applied. And the rule states you differentiate the numerator and denominator separately again and again till you get the value of the limit. So I tried to differentiate once. So 2t plus 2 by 3 the whole divided by 3 e to the power 3t. But still I'm getting infinity by infinity. That means I have to differentiate again. So what I did is I took the derivative of the numerator, that's 2, and the denominator. Okay, and finally I'm sure I'll get the answer. You saw before e power infinity tends to infinity. So the denominator will become infinity and the value will be 0 plus 1 by 9. And that's it. The variance is 1 by 9. So let's go for one more question. And it's kind of different. It's a function in which you will see many parts, or it's a piecewise function with more number of pieces than we saw before. Okay, so as always we have a random variable x which follows the PDF given by this. So you can see 1, 2, 3, 4. From minus infinity to 1, and then from 1 to 2, and then 2 to 3, and finally 3 to 4. And of course, this otherwise means it's defined. So we have 1, 2, 3, 4, and 5. So, as expected, the first question is find the value of k. And the second one, capital F of x, and that is our cumulative distribution function, or simply the distribution function. So I have the question right here. So as usual, it's a PDF, and PDF means if you add from minus infinity to infinity, the value will be 1. Now I'm going to split the integral from minus infinity to 1, and then 1 to 2, and then 2 to 3, and then 3 to 4, and then so you get something like this. The first and the last will disappear because you can see the function value from minus infinity to 1 is 0, and from 4 to infinity is also 0. And in between we have the function values k into x plus 1. In the next one it's like k into x square, and the third one kx cube. Now let's go for integration. That's very easy integration. X becomes x squared by 2, and then integral 1 dx becomes x cubed by 3. Put upper limit minus lower limit and use a calculator or take LCM, simplify. Yeah, it's a weird value. K is equal to 12 by 631. Now what we do is we just substitute the value of k in the PDF. So you're going to get something like this. Now let's go for the last part, which is very, very important. So it's a cumulative distribution function, and we know that we try to sum up the probabilities. We just sum all the probabilities to any desired number you like. And this is a more practical definition. And by the way, our PDF is right here. So let's start. And as usual, the last value I'm going to integrate, and I get 0, I put it here. And for the next value, I start with the lower limit. What's the lower limit? 1. So I'm going to write 1 to x, because I'm trying to accumulate all the probabilities in the interval 1 to 2. So I start with 1, and the upper limit is x, and the function value is x plus 1. Anyway, for integration's sake, I'm going to write t plus 1, and I'm going to integrate right here. T plus 1 becomes t squared by 2 plus t within the limits 1 to x. Put the upper limit and lower limit, you'll get this. So we have the integral value. Now we have to replace. Okay, that's it. Now I have to accumulate the value from 2 to 3. I have to accumulate the probability values from 2 to 3. So the integral will start from 2 to x, and the function will be 12 by 631 and t square dt. But wait a minute, this is the accumulation from 2 to 3, but we have already accumulated from 1 to 2. So what I do is I'll use the end point 2 in this function. I'm going to use the end point 2 in this function, so that I'll get the sum of the probability from minus infinity to 2. Look at this. I'm going to find the sum of all the probabilities from minus infinity to 2. And it's very easy. I'll just plug in 2 over here. So I get 12 by 631 and 4 by 2 plus 2 minus 3 by 2. So this will give me the sum of the probabilities from minus infinity to 2. And this gives me the sum of the probability from 2 to any number between 2 and 3. So we will add them up. Okay, that's how you got this 30 by 631. Now we have to integrate this, and that I'll be doing on the left side of the screen. T square becomes t cube by, okay, and that's it. So look at this. This step gives you the sum of the probability from minus infinity to any number up to 2. And if you look at this step, you will get the probability from minus infinity to any number up to 3. So once we substitute this value, okay, so can you guess the next step? So we have reached accumulating till 3. So the first thing I'm going to do is I'm going to plug in this value in this function so that I get the sum of all the probabilities from minus infinity to 3. I'm going to plug in the end of this interval in this function so that I get the sum of all the probabilities from minus infinity to 3, and that will be 30 by 631 plus 12 by 631 into 27 by 3 minus 8 by 3 plus, now I want the sum of the probabilities from 3 to 4, or rather any number between 3 and 4, and for that I'm going to integrate this. So I'll integrate from 3 to x the function 12 by 631 t cube dt, and that's exactly what's going to happen in the next step. Anyway, I've simplified this, so okay, and now let's go for the integral value, and the integral is right over here. Substitute. Okay, now look at this. Our PDF is not defined, or actually it's defined, the value is given to be 0, but we need a function value after 3. Now you can see that from minus infinity to 1 the sum of the probability is 0, and from 1 to 2 you can use this function and find the probabilities, and from minus infinity to 3 you can use this function, and from minus infinity to 4 you can use this function, and it's clear that once you exceed 4 the function value will be 1, and that's it. So we have the cumulative distribution function for a very complicated PDF. Let's end this video here. In the next video we will be discussing the special distributions. We'll be discussing binomial, Poisson, hypergeometric and negative binomial, and later on we will move on to the special distributions, normal and gamma. So till then, bye.